Hello Gujarat, welcome to VASISHTHA Ji, here at IITS and NRS. Today we discuss about the next topics of the JW advanced problem, that is Newton's laws of motion part 2. This all the questions are from the previous year's examination. Now what is the first one? Let's see. So let me discuss the first problem. A particle of mass 10 raised to minus 2 kg is moving along the positive x direction under the influence of the force F is equal to this one. So how much force is given to us? So F is equal to minus K upon 2x square, where K is given to us, that is equal to 10 raised to minus 2 Newton meter square. Now at the time t is equal to 0, the particle is at x is equal to 1 and its velocity is 0. So let's do the figure so your idea will be clear. Suppose this is the x axis and now consider somewhere here the x is equal to 0 and somewhere here it is supposed to be x is equal to 1. So initially when the t is equal to 0, particle is somewhere here. So let's draw the particle. So this is the particle at the time is equal to 0. Its initial velocity is 0. So let's take v0 is equal to 0. This initial velocity is given to us is what? 0. Now what we have to find in this case? Find its velocity. So we have to find the velocity when the particle is reached at the x is equal to 0.5 meter. So somewhere here consider the x is equal to 0.5. Let's see. So here the x is equal to 0.5. Now the force is given to us, F is equal to minus K upon 2x square. So its negative sign indicates its force is towards negative direction. Negative sign indicates its force is towards negative direction. So its initial acceleration is also towards the negative x direction. Yes or no? So that's initially the particle is at rest. So particle starts its motion along a negative x direction. So let's draw the figure with the acceleration. So acceleration is in this direction. Okay, so it starts moving along a negative x direction. We have to find out the velocity. So how to get the velocity? Let's see, we write down the equation. So velocity is equal to actually this dx by dt. Velocity is equal to what? Dx by dt. But right now x is not given, so we are not use this equation. Okay, if x is given, then use the equation, no problem. Right now the force is given. So you convert the force into the acceleration and acceleration is converted into velocity. We just go through this like this. So force is converted into acceleration and acceleration is converted into velocity. So you just think some equation like this. So force को acceleration में कैसे convert कर सकते? See. So write down this acceleration is equal to force upon mass. Okay. Now how to convert the acceleration in terms of velocity? Now let's see. If you write the value of the f, then f is equal to minus k upon 2x square. So f is equal to minus k upon 2x square, and that is a 1 upon m. So you write the equation of a in such a way. So you just take you write the equation of a in terms of x. Okay, यहाँ पे x है. See, what is the given here? X. So you write the acceleration equation in terms of x. तो कैसे लिख सकते हैं? तो simple सा equation है. Acceleration is equal to v into dv by dx. Acceleration is actually dv by dt also. Okay, but that is another form of acceleration. We write in terms of x. Right now we have to finding out the velocity, and right now x is given here. Here the terms is x. Okay, so put this value here. What you get? Acceleration is equal to minus k upon 2m into 1 upon x square. So take this whole the dx terms on the right hand side and remaining velocity terms on the left hand side. So answer is what? V dv is equal to minus k upon 2m into 1 upon x square dx. This is your answer. Okay, now you take the integration and finally you get the velocity. So before we take the integration, what we are doing? See, first you choose the limits. So that's initial is 1. Okay, and finally final position is supposed to be x. ऐसा मान के चलो. Then after we put x is equal to 0.5. So now take the integration in this case. Let's see. On both sides you take the integration. So integration. Now what is the velocity of v? Suppose 0 to v. Initial velocity 0 है तो 0 to v. Means v0 to v ऐसा लिखो. v0 is equal to 0. v0 is equal to what actually? 0. So So v0 to v. So initial position is what? Suppose x0 to x. Now put this value, so you get the answer v square by 2. The limit is 0 to v, and it is equal to minus k by 2m. That's 1 upon x square comes in numerator. That's x raised to minus 2. X raised to minus 2 का integration. That's x raised to minus 2 plus 1. So x raised to minus 1 upon minus 1. Limit is 1 to x. Okay. Now you just simplify this equation. So after simplification, v is equal to under root a upon m into 1 minus x upon x. Okay, this is your answer. This is what? Your answer. If you want to write down the direction, if you want to write a direction, then direction is along the negative x direction. Along negative x direction. Negative x direction में that's velocity. Okay. Now where you want a velocity? Where you want a velocity? So you want a velocity at x is equal to 0.5. So put the value of x is equal to 0.5 here. Put equal to 0.5 and find the v. So this one is in, you just try to solve out this problem by yourself, and after calculation you get this minus 1 meter per second. So v is equal to minus 1 meter per second. Why I am write the minus here? Because you write the answer with direction. Right now this is the, okay, that's root k by m 1 minus x upon x, that is the velocity. But when you put the different value into this equation, you get the 1. Okay, but use the negative sign because of direction, along negative direction. So that is the first problem. Now what is the second problem? See, so our second problem is find the time. आपको time चाहिए, so find the time at which it reaches the x is equal to 0.25 meter. So when it is reached somewhere here, see, somewhere here it is x is equal to 0.25. When the particle is reached somewhere here, how much the time is what? So it starts the motion at t is equal to 0, and we find the time. So convert the velocity into time. You just convert the velocity into time. So velocity equation आपके पास यही. So what is v? So v is equal to, now use this equation dx by dt. Okay, and you take this terms dt on one side. So what you get? See, finally. So root k by m 1 minus x upon x. Root k by m 1 minus x upon x, 1 minus x upon x is equal to, that is a velocity. So it is velocity is equal to dx by dt, this equation. Okay, right now we use here. So what we get, it is equal to dx by dt. So take the dt on this side. So dt is equal to, take this whole terms on this side. So that is becomes root m upon k into, this is becomes reverse, x upon 1 minus x dx. Okay, now you try to solve out this problem by the taking of integration. So integration लोगे आप, तो इसकी लिमिट्स आपको क्या रखनी होगी? So integration में लिमिट आपकी हो जाएगी, that's integration 0 to t, and that's integration from 0 to x. x is equal to 0.25, तो आप डायरेक्टली 0.25 रखो तो भी प्रॉब्लम नहीं है. So here you put thus x is equal to 0.25 meter. Sorry, x initial कितना था? My mistake. X initial आपका कितना था? See here it is given. Initial x is equal to 1. So you start from the 1. Okay. You start from the 1. So 1 to 0.25. 1 to 0.25. So you just try to solve out this integration by yourself. So after calculation, you get the answer, and that is equal to 1.48 seconds. After calculation, you get this answer. So integration, you just try to solve out this problem by yourself. Okay. So that is the first problem. So everybody note this. Then after we comes to this next one. Okay. So let note it. First one, second one, and the third one. Let's come to the next problem. Okay, now what is the problem statement? a smooth semicircular wire of a track having a radius is what r is fixed in a vertical plane. See the figure, मतलब figure भी given है, figure कुछ ऐसी है, see. So this type of figure is given to us. That is a semicircular wire which is placed in a vertical plane. So that is a vertical plane. Now let's come to this next one. Vertical plane. One end of a massless spring of a neutral length is 3r/4. मतलब कि neutral length इसकी 3r/4 है. Is attached to the lowest point O of the wire of the track. मतलब कि इसका lowest point जो है और lowest उसका one end जो lowest point पे कुछ fix किया हुआ है. So this is the fixed at this one. तो यहाँ पे this is what fixed. ऐसा कुछ given है. Now what is this next one? A small ring of a mass m, which can slide on the track is attached at the other end of the spring. So other end किसके साथ join है? So this one. So this is the ring. Actually यहाँ पे P पे ring है. So at P, what is this connected? One ring, and how much of the mass of the ring? Suppose the mass is supposed to be m, and it is given to us. So don't worry about this. Now, which can slide on the track attached to the other end of the spring. The ring is held stationary at the point P. So underline this one. Initially, the ring is held stationary. मतलब वो rest पे है. Such that the spring makes an angle of 60 degree. कितना angle बनाता है? 60 degree with the vertical. The spring of constant K is mg by r. Spring constant is mg by r. So let me write the data. Theta 60 है, and the K is equal to is what mg by r. So to write down, so K is equal to mg by r, and thus initial condition is this one. Angle is equal to 60 degree. That is a given one. Consider the instant when the ring is released. आपने मान लो कि रिंग को रिलीज कर दिया, तो आपको फाइंड क्या करना है? ड्रॉ द एफबीडी, फ्री बॉडी डायग्राम. फर्स्ट यू ड्रॉ द एफबीडी एंड द सेकंड वन डिटरमाइन द टेंजेंशियल एक्सेलरेशन. तो आपको फाइंड करना है टेंजेंशियल एक्सेलरेशन at is equal to what of the ring and the normal reaction of the ring. So n is equal to. So you get this two answer. Okay, first we draw the FBD, then after we solve out the second problem. So how to draw the FBD? See, so first it is connected to the spring. What is the original length of a spring? Initial length of the spring is given to us, and it is equal to 3r/4. Yes, that's one. Okay, so initial length कितने given है? मतलब original length, neutral length. What is the neutral length of a spring? So length of spring is equal to 3r/4. This is the given data. These are the given to us. Now we are finding out. First we draw the FBD. So let me draw the FBD. So first the spring is connected here. So it is considered as a Fs. The spring force is like this. Now the second one is contact force. That is a normal force. So draw the normal force here. So that is the radius. If it is radius, then normal force must be on the radius. Normal force must be on the radius. Okay, and the mg is downward side. So this is the mg. So that is FBD. First case is over. Okay. Now you release this ring at this position. तो उस पे कुछ force apply हो रहा है, तो उसका tangential acceleration find करना है. So let me draw the equation figure of the tangential acceleration. तो मान लो कि वो इस डायरेक्शन में ऐसे टेंजेंशियल एक्सेलरेशन 80 से मूव कर रहा है. ओके, इट इज मूव टेंजेंशियली somewhere here 80. So let we finding out the two data here. N is equal to what, and second one is 80 is equal to what. So first we find what is the change in length actually. Change in length मतलब इस length को find करते हैं. तो AR होगा, this is R, it is also R, thus both are the R. This angle is a 60 degree. So मतलब कि equilateral triangle बना, so that angle is which one? 60 degree. This angle is which one? 60 degree. So यहाँ पे Z बनता है, see this one is a Z. So angle भी 60 हो जाएगा, angle भी कितना हो जाएगा 60. तो यहाँ पे अगर आपने angle बनाया ऐसे, this A line पे, suppose you form this angle. तो ये भी कितना हो जाएगा 60. तो एंगल भी कितना हो जाएगा 60. मतलब ये सभी एंगल्स ऐसे 60 हो जाएंगे. इक्विलेटरल ट्रायंगल फॉर्म हो रहा है. So that is our case. Now we finding out then. So you just take the balancing. तो बैलेंसिंग आप कंपाउंड से लो, चलो तो यहाँ पे P पॉइंट्स है, P पॉइंट उसका यहाँ पे फोर्स है N, this is the N, mg का कंपाउंड यहाँ पे लो, टेक द कंपाउंड, so mg cos 60, take the compound of fs here, so that is what fs cos 60, ये हो गया first one. Now take the forces along this direction, तो ये same points P पे, same points P, ये force यहाँ पे भी आ जाएगा, so this is fs sin 60, मतलब यहाँ पे ड्रॉ करना, मैं यहाँ पे साइड में ड्रॉ कर रहा हूँ, और ये कंपाउंड्स भी यहाँ पे आ जाएगा, so this is equal to what mg sin 60. So that is a complete FBD of the body, complete FBD of the ring, this side. And where is the acceleration? तो इसी डायरेक्शन में आपका acceleration है somewhere here, so that is acceleration here. And V gives us name AT, so that is AT. So FBD हो गया, but आपको इसमें बैलेंसिंग करनी N फाइंड करना, पहले तो F फाइंड करना होगा. So thus new length is R, equilateral triangle, so that is R. तो change in length कितना होगा? So change in length of a spring x is equal to final length minus initial length is what 3r by 4. So that is equal to 4 minus 3, that is r by 4. You get the first answer. Now spring force is what? Spring force Fs is equal to क्या होता है kx. So k is equal to what? That is mg by r. mg by r multiply by x is r by 4. So x is r by 4, r cancel out, this is becomes mg by 4. Now you get the fs also. You take the balancing of this one, balancing of the point P along the radial direction. What do you get? See, along radial direction. So along radial direction, what do you get? N plus fs cos 60 is equal to mg cos 60. So N plus Fs cos 60 is equal to mg cos 60. So you just calculate this answer. After calculation you get this. N is equal to you get the answer 3mg by 8. So N का आंसर मिल जाएगा 3mg divided by 8. And now how we get the acceleration? So acceleration के लिए second figure ले लो चलो. So this one. So you just observe this, hold this one from the ground. You observe from the ground. So F net is equal to ma, Newton's second law. Apply the Newton's second law. What do you get? The force is equal to mat. Yes or no? The force is equal to what? mat. So apply Newton's second law. F net is equal to what? ma. F net कितना है सी? What is F net? Fs sin 60 plus mg sin 60. So Fs sin 60 plus mg sin 60 is equal to mat. Everything is known, only at is unknown. So find at from this one, and after calculation you get this answer, and it is equal to 5 root 3 upon 8 into g. 5 root 3 upon 8 into g. So after calculation you get the answer. Okay. So you must be understand this problem properly. Here we take the balancing of the point P along radial direction. We apply Newton's first law. Newton's first law. Along tangential direction we apply Newton's second law. Okay, so both the law are used in a same exam, in a single example. So everybody note this. Then after we comes to this next one. Let's note it. Now this one, and now this one. Okay, let's come to this next problem. Okay, what is the problem statement? See, another problem. The two block of mass 2.9 kg and the 1.9 kg are suspended from a rigid support as by the two unextensible wire. Each of the length is 1 meter. See the figure. So this type of figure is given to us: 2.9 kg, 1.9 kg. Okay, and the length of the both wire is 1 meter. It is given to us. Now the upper wire has a negligible mass. So this wire does not contain any mass. and the lower wire has a uniform mass of 0.2 kg per meter. So wire itself having a length is 1 meter. मतलब इस वायर को आप ऐसे ड्रॉ करो तो आपका आइडिया थोड़ा क्लियर हो जाएगा. Let's we draw this wire like this. So this wire having a some mass itself, and how much it is a 0.2 kg per meter, but its length is 1 meter. So total mass of the lower wire is what? 0.2 kg. Now the whole system of the block and the wire is supported have an upward acceleration of 0.2 meter per second square. So this is the acceleration of this one. So यहाँ पे acceleration ले लो A. So A is what? So A is equal to 0.2 meter per second square. Take the G is equal to 9.8 meter per second square. So यहाँ पे आप G कर लो, चलो. That is the G. Okay. Now find the tension at the midpoint of the lower wire. मतलब somewhere here. So wherever you find the tension, you just break the system over there and apply the Newton's second law, nothing else. Okay. So let's break the system somewhere here. चलो break the system at the midpoint of this one. So अगर midpoint है तो इसका half mass lower होगा, half mass upper होगा. So 0.2 kg. So this one is a 0.1 kg. What is the mass of this lower part total? This is the 0.1 kg and here it is the 0.1 kg. Consider the tension at this point is supposed to be T1. यहाँ पे tension T1 ले लो, suppose you have to find this data. Okay, so what is the total mass supported at the lower side? What is the total mass supported at the lower side? 1.9 kg and 0.1 kg. So total mass हो जाएगा आपका 2 kg. So you draw the FPD for the 2 kg only, and the tension is what? T1. Let me draw the figure. So that is a 2 kg. What is the upward force? Tension T1. What is the downward force? mg. And what is the acceleration? A. Apply Newton's second law and you get the answer. So T1 minus mg is equal to ma. Okay, so mg is known, ma is known, so find the T1. So you just get the answer of T1 from here. Let me write the answer. First we solve the second problem. Then after we write it, okay? So what is the second problem? Find the tension at the midpoint of the upper wire. So upper wire मतलब इस point पे. But this mass is negligible. So total mass is supported by this one. तो यहाँ पे आप tension suppose consider करो T2. And total mass कितना होगा? 2.9 plus 0.1. 2.9 plus 0.1 3 kg, 1.9 plus 0.1 2 kg, total हो जाएगा 5 kg. So draw this FPD and you break the system here. Okay, so T2 and this whole system. How we draw the FPD? Let's see. So second case में आप draw करो FPD. So what is this total one? 5 kg. Upward force tension T2, downward force mg, and the whole system is moving upward with acceleration is what? A. This is the given data. Now apply the Newton's second law. फिर से so T2 minus mg, but this mg and this mg different ना. यहाँ पे m is equal to 5, in this case m is equal to 2, and this is equal to again ma. You can say suppose it is m dash. So we are not making any mistake. Okay, and that is equal to m dash. So find the T2 from here. So T2 is equal to find out. After calculation, you get the answer. T1 is equal to, your answer is 20 Newton, and T2 is equal to, your answer is what? 15 Newton. You get this answer. Okay, and we solve this problem with the ground frame reference. We solve this problem with the ground frame reference. We observe the whole system from ground. We observe the whole system from ground. Then we apply the Newton's second law because whole system is moving upward with acceleration in. So the same problem you just solve by the using of pseudo force. So that is in homework. Okay. So solve full problem by using of pseudo force. मतलब FP concept. And that is in homework. You just try to solve out this problem by yourself. Okay? Clear? And not this one. Chalo. Not this one. And again, not this one. Now let's see. That is a problem which is given to us. A uniform rope of a length L and the mass M is lying on a smooth table. Is pulled by a constant force F. मतलब कि this type of situation. this is the ground smooth table on which the rope is placed having some mass. इसका mass is supposed to be m and length is l, and how much force is applied on it, F. This type of data are given to us. What is the tension in the rope at a distance L? At a distance L from the end where the force is applied. मतलब यहाँ से आप कोई भी end ले लो, इसको थोड़ा side out कर लेते हैं, M and L. You just consider by yourself. ओके, सब वहाँ पे M and L है. यहाँ पे कोई भी distance L ले लो, चलो आपने यहाँ पे कोई distance L ले लिया. So find the tension in the rope. आपको इसमें tension find है. What do you have to find out? Tension. So draw the tension force and apply the Newton second. You get this answer. यहाँ पे tension T होगा. So यहाँ पे भी tension T होगा. Okay, so that is a given data. You just break the system, apply the Newton second law. First, whole rope is moving with constant acceleration. Yes or no? तो पूरी system कुछ acceleration ऐसे जाएगी. What is acceleration? So acceleration is equal to net force upon net mass as per the Newton second law. So net force कितना है? F. Net mass कितना है? M. This is the given one. Okay. Now you want to finding out the tension. You break the system. You just side out. So that is L. तो total length L है. तो ये remaining कितनी हो जाएगी? L minus L. What is the remaining one? L minus L. So you just draw this portion only. So इतने portion को draw करो. उसको कौन सा force pull कर रहा है? T. With what acceleration? A. Okay. उसका mass आपको supposed to be m dash है. तो आंसर क्या हो जाएगा? As per the Newton second law, you just write it Newton second law. F net is equal to m dash A. Okay. What is F net over there? T is equal to what is m dash? Total mass of the wire is m. So what is the mass of the small portion? That is the mass density. So mass density is given by m upon L. Mass density is given by m upon L into length of the wire. So that is a L minus L into acceleration. Acceleration is equal to force upon small m, or sorry, capital M. यहाँ पे mass आपको given है capital M. So write down that is a capital M. So if anything is cancelled, then cancel it. So M cancel, M cancel. What you get? You just write the answer in this way. F यहाँ पे ले लो, F L को separate कर दो. So 1 minus L upon L. So you get the direct answer. You get this answer. That's very simple problem. But suppose ऐसा कुछ पूछा है कि variation of T with respect to length है, तो आप कैसे आंसर लिखोगे? See, ऐसा भी यहाँ पे क्वेश्चन हो सकता है. Variation of T, variation of tension with length. ऐसा पूछा नहीं है, but how to get this? So you write the answer. So T is equal to force into what we get? 1 minus L upon L. So 1 minus L upon L. This is your answer. So this equation is exactly like a straight line. See, y is equal to mx plus c. इसको open bracket कर तो आंसर हो जाएगा. So f minus f upon L into L. इसको rearrange करो. So t is equal to minus f upon L into L plus f. So this equation is exactly similar as a y is equal to mx plus c. So this variation is a straight line equation. Okay, if you draw the graph of t versus L, then what is its maximum value? What is its maximum value? So its intercept is f. Intercept is f. So यहाँ पे मान लो कि f है. Its slope is negative. M is equal to minus f upon L. So slope is negative. So draw the line like this up to this point. Okay, and when you reach somewhere here where the force is, the tension is 0, it means यहाँ पे tension 0 होगा when L is equal to L. So this intercept is L is equal to capital. So that is a variation of tension in the wire with respect to length from the end where the force is applied. Clear? So everybody note this. This one and this one. Okay, thank you very much to all of you, and in the next session again we comes with the friction one and JEE advanced problem which is based on a previous year's examination. Clear? And finally, if you like this video, then you must be share it and subscribe the channel for more updates. Thank you very much to all of you, and finally VASISHTHA.